This is the solution to parallel circuit example number 2. So similar to the series circuit example number 2, ideally you are completing this example on the left-hand side of your notebook and taking just a minute or so to recreate that diagram into the left-hand side of your notes. And you'll see this image embedded within the slide as well next to the video. So we're going to go through the steps to solving for a parallel circuit, which, as I mentioned previously, these steps can be a little bit more tricky than solving for a series circuit, but with practice it definitely becomes a little bit easier. So our first step when solving for a parallel circuit is going to be to find the total resistance. So similar first step to solving for a series circuit, we want to find the total resistance, but in order to do so for a parallel circuit, it's going to be a little bit trickier in that we have to take the reciprocal at each resistor. So we're going to start by just writing the equation out, so 1 over RT. And in this case, it's kind of nice because we only have 2 resistors. So I'm going to write equals 1 over R1 plus 1 over R2. So R1 in this case has a resistance of 12 ohms, and R2 has a resistance of 24 ohms. So how you go about solving this part is really up to you. I'm going to just illustrate how to do it on my calculator in the easiest way possible, but if you are comfortable doing this step, just all in one step in your calculator, that's fine as well. So I'm going to figure out what 1 over 12 is, and in order to do this on the calculator, you want to just set it up using the division function. So 1 over 12, and then I'm also going to add that to 1 over 24. And that gives me an answer of 1 over RT equals 0.125. So this is where a lot of students run into trouble. They think that this is the final answer for resistance, although it's not. You still need to take the reciprocal of this answer. So our last step is going to be to put 1 over 0.125. And that's going to give me the total resistance, which in this case, it's nice because it ends up being a whole number, and we get a total resistance of 8 ohms for this parallel circuit. So if you got through this step on your own, that's definitely something to pat yourself on the back for. This is a tricky step for sure, so maybe even just pause the video, go back and rewatch it until you feel like you're fully understanding how to find total resistance, because then the following steps are pretty simple moving forward. So the second step is going to be to find the total current. So I'm going to write IT, and we're going to use the equation, the voltage of the battery divided by RT. And if we look here, the voltage being supplied by the battery or energy source is 24. And we're going to divide that by the resistance that we found in the previous step. And this is pretty simple math. We get 24 divided by 8 is going to give us a total current of 3 amps. And then last but not least, our final step is to find the current that's running through each resistor. And then when we add those together, they should hopefully add up to 3. And that's just a nice way that we can check our work at the end. So the last step is to find, I'm just going to write I, or current, through each resistor. Okay, and so we only have 2 resistors here, so for R1, I'm going to use the equation voltage divided by resistance. We're going to use that same voltage, 24, but now we're going to divide it by the resistance at the resistor. So 24 divided by 12 gives me 2 amps. So I have 2 amps of current running through this pathway. And now for resistor 2, I'm going to divide the voltage of the battery, so 24, divided by the resistance, which is 24. And that's going to give me a current of 1 amp running through this pathway. And then you can see here that when I add those together, it gives me a total current of 3 amps, which is what I found in step 2, and I know that I solved correctly. And that's the solution for parallel circuit number 2.